Hello and welcome. My name is John Hare, a DB2 Technical Enablement Specialist with IBM, and you're viewing DB2 Autonomics, a brief demonstration of some of DB2's key autonomic features, features that are easy to implement and will save time for both administrators and developers alike by effectively eliminating the need to spend hours and hours configuring, monitoring, and tuning their DB2 databases. Now, data professionals can spend more time planning, further developing, and improving the quality of information resources that your organization relies on. I will talk a bit about Autonomics and DB2's commitment to them. Next, I will show you how simple it is to alter a table space currently not using automatic storage to use DB2's automatic storage feature. Then I'll demonstrate using the Design Advisor how to tune a query. The Design Advisor will provide index recommendations that we will implement and improve the query's performance. Finally, I'll give you a look at the self-tuning memory manager in action, as it automatically increases resources from a buffer pool memory heap to accommodate for an increasing load upon the system. IBM is committed to building autonomic features and tools into DB2. By choosing DB2 or any IBM information system, you will receive the added benefit of saving more time when compared to our competitors. Let's take a look at some of DB2's autonomic computing features. We will demonstrate some of DB2's key commitments to autonomic computing, including self-tuning memory manager, automatic storage, and the design advisor. This chart has characterized autonomic computing as having 4 specific areas. As the chart would imply, DB2 has made a strong commitment to autonomic computing in all 4 areas outlined. An autonomic system is continuously analyzing its environment and adapting to changing conditions, all the while minimizing any overhead that self-configuration might impose. DB2's self-tuning memory manager is the epitome of this definition. Its intelligent algorithms will assess when and how frequently to check and make adjustments to all the participating memory heaps. In fact, almost all database memory consumers can be configured to take advantage of STMM. Moving on, DB2's table spaces and table space management has become easier and easier for database administrators. With every new release of DB2, DB2 has offered automatic storage solutions for its database since version 9.1. Here we are simply and quickly altering a table space, VPS large, that is not currently utilizing the database's defined automatic storage. Next, we alter the table space to asynchronously rebalance the table space to its new containers. And again, this is asynchronous, so this should come back fairly quickly. And finally, we will take a snapshot of the table spaces. We will locate VPS large table space, and we will see that it is now configured for automatic storage. Here we will take the snapshot. Automatic storage will stripe your data across as many containers as you define for it. It is defined when you create a database. It is defined by default, so databases by default will utilize automatic storage. So we take a look at the snapshot, we locate the VPS large table space that we altered. And we can see by looking at the using automatic storage description that it is set to yes, and the auto resize is enabled. You can take a look at the size of the table when it was last resized automatically, another autonomic feature. And you might notice right now that the rebalancer mode is reverse. So it's actually still rebalancing the data or the extents. And the number of containers is currently 3. When that rebalancer finishes, it will be down to 2, but there's no interruption in database availability. Now we're going to move on to the design advisor. Here's a query that we're going to be using. It's a simple select statement. We have put it into our Data Studio SQL editor. We're currently connected to the LabDB, and we simply, before doing anything, are going to run the Visual Explain tool. And this is going to give us an access plan. And on that access plan are various nodes and various costs associated with those nodes. The costs are cumulative, moving left to right, bottom to top. to interpret the chart. And you can see at the very top node, we can inquire upon it. We can see it has a relative cost of 704 Timerons. Has some CPU costs and some I/O costs associated with it. These I/O costs and CPU costs are the main contributors to determining what that Timeron value is. Timeron value is not comparable between systems. It has to be the same system, the same database. It is a relative value specific to the system and the inputs. So right now we're going to invoke the design advisor. The design advisor has a graphical form. You can find it in a graphical format, but here we're using the DB2 advise command. So here we're just going to output this DB2 advise to a file and the actual recommendations, and we're going to go in and see the actual recommendations being made for an index in that file. So we'll call this file advise.out. And let's take a look inside that file. And we can see a lot of different metrics available for you here. Up at the top, you can see that they have overall Timerons. You have the overall Timerons of 482, and that would be the improvement if you implemented these recommended indexes. You see it gives an assessment of 31.92% improvement. Gives you the actual DDL. So this file could be run directly to create these indexes. You can see there might be some unused indexes, but again, you need to exercise caution when assessing any recommendations for unused indexes. So we're going to run that DDL. We're going to create those indexes. So this file just has those that same DDL that we looked at in the advise.out. And we've created those indexes. If we go back now to the Data Studio, we can simply rerun that query or reanalyze that query with Visual Explain to see if the access plan had changed. In the earlier access plan, there was a table scan, so hopefully we won't see that. You can briefly see it here. Close that up. That's the old one. Generate a new Visual Explain. And if we open that up, we can see that the Timerons have been reduced to that 482 as predicted. And we can also see at the bottom that everything's being accessed by indexes. We no longer see TB scans, we see IX scans. And that is, in general, a much better situation to be in. Now we're going to take a look at the self-tuning memory manager in action. We're using the virtual production system to put a load on our database. Virtual production system comes with a number of scenarios that we use for this. In particular, we're going to use an OLTP load. And what we'll be doing here is we'll be creating such a load that the buffer pool will increase automatically under STMM. And that will be the objective of this demonstration. So right now we're going to our virtual production system. As you can see, we're choosing a mixed load. We're updating the number of users on it to, I believe, 20. And we start our load on the system. Refresh every 2 seconds. And as you can see, the load gets started fairly quickly, and we'll shoot up to about 200 transactions per second. Now what we're going to do is we're going to open a second tab, and we're going to drill into the OLTP scenario. There are some sub-scenarios, one of them being the STMM sub-scenario. As we quickly drill into that sub-scenario, you can see all the database heaps that are participating in STMM. You have some control over resetting those values. On the bottom, you'll notice the buffer pool is set to a current value of 1,000. We're currently still running that load in the background. Increase things up to about 350 transactions per second. Bump up the number of users. Shrink the think time. And what will happen, as you see, is the buffer pool actually has been increased to 1,500 dynamically.
Thank you for watching DB2 Autonomics. When talking about DB2 and its commitment to the integration of autonomic features, this short demonstration only starts to scratch the surface. For more information, see other related features available on channeldb2.com. Finally, IBM is committed to building autonomic features and tools into DB2. By choosing DB2 and any other IBM information system, you will receive the added benefit of saving more time when compared to our competitors.